Now let us look at one simple numerical example for third degree price discrimination. Now, suppose there is a monopolist, and suppose monopolist can identify two sets of consumers. So his consumers are non-students and students. Non-students and students, right? The demand function for students is given by QS is equal to 100 minus 8 PS. And demand function of non-students is given by Qn equals to 100 minus 4 PM. The total demand is QT, which is Qn plus QS. The marginal cost is given as $2 per unit, right? $2 per unit. So the first case is, what is going to be the monopolist profit in case if he's going to charge a uniform price, right? So first thing is that. So what are monopolist's profit in case of uniform pricing? In case of uniform pricing, right? So monopolist is not discriminating between the two kinds of customers, so he's going to charge the same price, right? He's going to charge the same price. So what happens is, since he's going to charge the same price, so the price which he's going to charge non-students would be equal to the price which he's going to charge students. Let's say that is equal to PU, right? That is the uniform price, right? That is the uniform price. So what is going to be my profits? Profits are going to be revenue from the student market, PSQS, plus revenue from the non-student markets, PN, QN, minus the total cost, minus total cost. Fair enough. But in place of PS, I can write PU. In place of QS, I can write 100 minus 8 PS, but that 100 minus, in place of PS, I can write PU, na? Okay. In place of PN, I can write PU. QN is 100 minus 4 PN. In place of PN, I can write PU again. Minus 2 QN plus QS. Beta, what is QN? QN is 100 minus 4 PU, right? 100 minus 4 PU, that is QN, plus 100 minus 8 PU, that is QS. You with me? I can take PU common and I can add this up. So this thing becomes what? 200 minus 12 PU minus 2. And this thing becomes what? Your 200 minus 12 PU. 200 minus 12 PU. Fair enough. Okay. So this entire function is now the function of PU. I just need to find out with respect to PU and what is going to be my price, what is going to be my optimal uniform price, that is pi dash PU. I hope you guys can just differentiate that, and you'll be getting that as 224 minus 24 PU equals to 0. PU is going to be 28 by 3. This is approximately equal to 9.3. Fair enough. And what is going to be the profit? profit of the monopolist at price 9.3 is going to be? But I could have taken 200 minus 12 PU common. So it can become what? PU minus 2 into 1200 minus 12 PU. So it is 9.3 minus 2 into 200 minus 12 into 9.3. So once you solve this, you will be getting, I think, something like 645.33, something like that. And what is going to be the equilibrium output? Your capital QT is going to be what? 200 minus 12 PU. That is 200 minus 12 into 9.33. That is approximately equal to 88. That is going to be your output. Fair enough. Okay. Now, supposedly, in the second part of the problem, they say that why don't you find out if the monopolists can price discriminate, right? So, right, what are the monopolists' profit in case of third degree price discrimination? So what will happen there? What are monopolist profits in case of third degree price discrimination? In case of third degree price discrimination means that it can charge non-students or students different prices, right? So what happens there? That's what it is, right? So beta, I can write, what is my QN? QN is 100 minus 4PN, right? And QS is 100 minus this guy. So I can write PN as, I can write everything in terms of PN. How? 1 by 4, 100 minus QN, right? I can also write everything in terms of PS. That will be 1 by 8, 100 minus QS. 1 by 8, 100 minus QS. Fair enough? Okay. Then what do you do, right? So then what you do? We have already derived this case yesterday. You remember that? MR equals to MC, right? MR1 equals to MC and MR2 equals to MC, sorry. So in third degree price discrimination, MR1 equals to MC. So MR1 equals to MC means, or you can say MRS equals to MC. MRS, students. So it will be what? 1 by 8, 100 minus QS is equal to 2 because MC is same, na? And MRN equals to MC. That is going to be 1 by 4. 100 minus Qn equals to 2. I'm sure you guys can solve this up. Your QS star will come out to be 42. And Qn star will come out to be 46, right? Qn star will come out to be 46, right? So if you look at it, the total output is still the same as in the case of uniform pricing, right? So note that. total output is still the same. That is QS star plus QN star equals to 88, right? Right. But the point is, relative to the uniform pricing case, less is now sold in the market that is with a high demand, and more is sold in the market with a low demand. Right? So please write relative to the uniform pricing, right? Less is now sold, is now means in case of third degree price discrimination, is now sold in the market with high demand, right? That is in the what do you call um, market of uh, market of students, right? And more is now sold in the market with low demand. With a low demand, right? Okay, so the prices which are charged, I mean, you can just plug in the values. So what is going to be your PS star? You can just plug in the values. It is 1 by 8, 100 minus QS star. So it is 1 by 8, 100 minus 42. That will be 7.25. And PN star is going to be 1 by 4, right? 1 by 4, which is 1 by 400 minus QN star. And QN star is 46. Right. QN star is 46. That is 13.5. Fair enough. So the high demand, the high demand market is your non-student market, and the low demand market is the student market. So that seems to be right. Okay. And the monopolist's profit in this case is going to be, just write this, PS star QS star plus PN star QN star minus 2 capital Q star or QT star, which is QS star plus QN star. So you can just plug in all the values. I'm sure you guys can. So it is 7.25 into 42 plus 13.5 into 46 minus 2 into 88. So that comes out to be 749.5, which is more than the profits in uniform pricing. So in this case, if he price discriminate, he can probably make more instead of when he's not price discriminating, right? Okay, so this is what I wanted to do in this recording. Thank you, Beta.